Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to learn about some corrosion prevention methods in which cathodic protection is the most important one. So, what is the main principle involved in cathodic protection, which is useful for preventing corrosion reaction? And it is of two different types. And one is sacrificial anodic method, and the second one is impressed current cathodic protection. So, let us start with introduction to cathodic protection. The main principle involved in the cathodic protection is the metal which is going to be prevented from corrosion reaction is what we call it as base metal. What do we mean by base metal? Base metal, it is defined as the metal which is to be protected or prevented from corrosion reaction. So, initially if this base metal is acting like anode, this base metal it is acting like anode. So, what is the principle involved in this cathodic protection is the metal which is acting like anode initially is forcibly converted to behave like cathode. It is forcibly converted to behave like cathode by using some different kinds of means. So, let us see what are they. So, what is the principle involved in cathodic protection? The metal which is to be prevented from corrosion reaction is forcibly converted to behave like cathode. So that initially it is acting like anode and now it is converted forcibly to behave like cathode so that it is prevented from corrosion reaction. And I told you that the metal which is to be prevented from corrosion reaction is named as base metal. So there are two different types of cathodic protection. Let us go with one by one. First one, it is sacrificial anodic protection, and second one is impressed current cathodic protection. Let us start with the first one. So, using the same principle, whatever we have learnt in that cathodic protection, the same principle we have to apply for sacrificial anodic method. So, metallic structure which is to be protected from corrosion reaction is what we call it as base metal, as I told you, and this is connected to the more anodic metal. This is connected to the more anodic metal using a copper wire. That means we have to check the position of base metal in the electrochemical series. So, base metal position in the electrochemical series. So, we have to choose metals which are more anodic to the base metal. That means it should be present above the base metal in electrochemical series. So, it will behave like more anodic to the base metal. Say for example, I have chosen one buried pipeline. I just want to protect that buried pipeline, whether it is in soil or any marine system that is in the water. I just want to protect that buried pipeline. So, it is acting like base metal. So, it is made up of iron. So, I have to choose the metals in the electrochemical series above iron, above the iron position. So, they will behave like more anodic to the base metal. So, likewise, we have to choose the metal and it is connected to the base metal using one copper wire. So, that means initially the base metal is acting like anode. Now, we have connected that one to more anodic metal using one copper wire so that forcefully it is converted to behave like cathode. So, the base metal it is prevented from corrosion reaction. So, after connecting to the wire so that all the corrosion it is concentrated at a more anodic metal. As the more anodic metal it is sacrificing its life for this process to take place. That means for preventing the base metal from corrosion reaction, it is named as sacrificial anode method. Most commonly used sacrificial anodes are zinc, aluminum and magnesium. Zinc, aluminum and magnesium. So, let us discuss this point with a few examples. As I told you, common examples are zinc, magnesium and aluminum. In this case, I am going to consider sacrificial anode as zinc. So, this is what I told you, one buried pipeline. So, this I want to protect from corrosion reaction, or any hull or body of ship I just want to protect, or boat, any body of ship or boat which is made up of iron, or you can say any alloy of iron. I just want to protect that one from corrosion reaction. So, it becomes an example for base metal. Now, this buried pipeline is example for base metal which is made up of iron. So, above the iron that is present in the electrochemical series, I have to choose the more anodic metal. That means the metals which were placed above the iron in the electrochemical series will act like sacrificial anodes. If that is the case, we have to choose either zinc or magnesium as more anodic metals. So this zinc it is considered, or we can say magnesium can be considered, and it is made in the form of a block. This magnesium it is made in the form of a block. See here, it is made in the form of a block, as this is more anodic to the iron. How it is identified? Means this magnesium it is present just above the iron in the electrochemical series. That's why it is more anodic to iron. So this purest form of magnesium it is made in the form of a block, and it is connected to actual base metal, that is buried pipeline, which is made up of iron, using one copper wire. So then what will happen immediately? Initially this buried pipeline it is acting like anode. So now after connecting with this copper wire to a magnesium block, forcibly this buried pipeline will behave to act like a cathode. So then this magnesium will act like anode. So as a result, oxidation starts or takes place at magnesium block, and then magnesium involves in corrosion reaction. Hence, this buried pipeline, that is which is made up of iron, will be prevented from corrosion reaction. So where we are having a lot of applications for the sacrificial anode method. Say for example, as I told you, one buried pipeline. So that pipeline is used to carry any kind of natural gas or crude oil or some kind of chemicals which is present in underground, that is soil, or we can say marine environment. So all these things can be protected or prevented from corrosion reaction by applying the sacrificial anode method. So if you notice one more example, this is an underground structure or a pipeline or a cable which is present in the soil. I just want to prevent that one from corrosion reaction. So this is the pipeline which is in soil. I just want to protect that one from corrosion reaction. So it is connected to magnesium block. This is the magnesium block, purest form of magnesium. It is made in the form of a block, and this is connected to this pipeline using copper wire. So that what will happen? Initially this buried pipeline it is acting like anode. So it starts involving in corrosion reaction. Now after connecting to magnesium block, it is forcibly converted to behave like cathode. So this magnesium will act like anode. So it involves in corrosion reaction first, so that this buried pipeline will be prevented from further corrosion reaction. So this is an example. And the second one is, as I told you, hulls of ship and boats which are present in the marine environment. If you want to prevent that body of ships or boats which are made up of alloy of iron, by connecting those ship huge bodies to either zinc or magnesium block, and if it is connected using one copper wire, and simply we can leave that part into water, or we can say marine environment, then the body of the ship which is acting like anode initially will be forcibly converted to behave like cathode. So that is purely due to block of zinc or magnesium, so that it will be prevented from corrosion reaction. So this is one more example. And then example 3 will have this water stored in a container. So this is a storage tank which is made up of alloy of iron. So into which I have hanged, using one copper wire, I have hanged either zinc or magnesium block into the water. So this block itself will act like anode, so that the body of water tank which is made up of iron will be prevented from further corrosion reaction. So this is example 3. Water stored in a container can be prevented from corrosion reaction. So coming to this, sacrificial anode method, it is having one drawback. As I told you, we have to connect that base metal which is to be protected from corrosion reaction to more anodic metal in the form of a block using one copper wire. As and when that whole block it is start involving in a corrosion reaction, after some period of time it gets totally corroded. That means periodically it needs we have to change that blocks with new blocks of magnesium or zinc. That means periodically we need to monitor and change, or we can replace that old blocks with new blocks of magnesium or zinc. That means it is not a permanent solution for corrosion reaction to prevent. That means monitoring it is needed, and periodically we need to change the magnesium or zinc blocks. So for rectifying such kind of drawbacks, one more method it is implemented in cathodic protection, that is impressed current or cathodic protection method. Impressed current cathodic protection method, that is ICCP. Impressed current cathodic protection method. So in this method, the metal which is to be protected is considered to be the base metal, which we know very well. The metal which is to be protected from corrosion reaction is connected to an external battery with the help of an anode. New anode we have to choose. Generally, graphite will play that role. New anode means what will be the base metal that we are going to protect from corrosion reaction. Initially, it is acting like anode. So, for completing the cell, we have to depend upon one more electrode. So, for better anodes, we are going to choose graphite electrode. So, this graphite electrode is connected to this base metal with the help of one external battery. So, and then the external battery is able to produce DC current, that is a known quantity, that is which is more than the corrosion current we have to supply in reverse direction. A known quantity of direct current, it is passed through the electrolyte. When the applied current it is equal to corrosion current, the corrosion reaction immediately will stop. So as I told you, one inert graphite electrode, it is connected to the cathode with the help of one battery, and then a medium will play the major role. So electrical contact will be continued, and with the supply of this DC current which is greater than the corrosion current in reverse direction, then it is able to prevent the formation of corrosion reaction exactly at the base metal. So this is what we call it as impressed current cathodic protection. So this is a permanent solution, and that means we are changing the flow of electrons. Initially the flow of electrons will be from base metal, that is anode, to the cathode. So now what we have done, so by connecting this graphite electrode as anode to this base metal, we have reversed the flow of electrons with the help of external DC supply. So if you notice this figure, this is one transmission line, transmission tower, power transmission tower. So it is a permanent solution for preventing corrosion reaction for transmission line towers or power line towers. So various applications will include this type of ICCP, that is impressed current cathodic protection. It is used in various kinds of base metals, say for example open water box coolers, and then large storage water tanks which are made up of iron, and then buried pipelines which are used to carry oil, crude oil, natural gas, or different kinds of chemicals either in soil or in marine environment, and then condensers, and then as I told you, transmission line towers. I just have shown the example. This is nothing but transmission line tower. And then marine pipes, robust or huge size of marine pipelines. So for protecting all these type of metal bodies which are named to be base metals, we have to depend upon using one method, that is called impressed current cathodic protection. It is the best solution and a permanent solution when compared to sacrificial anodic method. So in today's session, we studied about different preventive methods for corrosion reaction. So first one, it is cathodic protection. What is the principle involved in cathodic protection and how many types are there? So it is of two different types. First one, it is sacrificial anodic method, and the second one is impressed current cathodic protection, that is ICCP. So this is the best suitable method for preventing corrosion reaction. So in the coming session or in the next session, we are going to start unit 3, that is polymeric materials. What is the nomenclature of polymers? Functionality, tacticity, kind of introduction we are going to study in the coming session. So that's all for today's class. Have a nice day. Thank you.